Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. In the previous lecture, we were learning counting rule and we study the counting rule for combination. Counting rule for combination is used to determine the total number of experimental outcomes of an experiment but in combinations form, and we use the symbol for the combination small n, and this combination we are choosing from the large set of data that is represented by the capital N. Today we will again repeat counting rule for permutation. So permutation and combination is almost same thing. The only difference between the permutation and combination is this, that if we disorder the combination, if we disorder the group of items, if we disorder the combination n, so it will be considered another experimental outcome, and that is why in permutation the number of experimental outcomes will be doubled, will increase. So combination and permutation is almost same thing. Permutation is also used to determine the number of experimental outcomes of an experiment in combination form. And in here we are choosing the combinations of n objects from the large group of set. I am again repeating that counting rule for combination and counting rule for permutation is almost same thing. In combination also we are selecting the combination of n objects, small n objects. We are selecting the combination of small n objects from the large capital, from the large set of objects, and we are using capital N for that. So combination and permutation is same thing. The only difference is order, tartib of the selected group of items. Let me clarify this by putting this mathematical notation for permutation. This P represent permutation, this N, capital N, represent the large group of object or the large group of data items or the large group of experimental outcomes, and this small n represent the combination of n objects, where n is a small n which represent the group of items, the subset of the large set that we choose, or the group of items that we choose from this large set of items. So P for permutation, this represent total experimental outcomes. You can say total experiments, or you can say total objects, and this small n represent the group of items that we will choose in combination form. So this is n factorial multiplied by capital N factorial whole divided by small n factorial multiplied by n minus n whole factorial. This is the formulation for the permutation. Now this n factorial cancel out with this n factorial, and this formula implies like this: n factorial whole divided by n minus n multiplied by whole factorial. So this small n factorial cancel out with this small n factorial, and now permutation formulation is this: Pn small n is equal to n factorial whole divided by n minus n whole factorial. This formula we will use to determine, to estimate the number of experimental outcomes of an experiment, but in the combinations form, in the group of items form. And this group of item we represent by using small n, and the large set of items we are representing by capital N. So let me further clarify this counting rule for permutation and difference between the permutation and combination by putting one example. I am clarifying this by putting example. For example, a food inspector is inspecting 5 different food items like A, B, C, D, E. These are the 5 food items. So you can say the experiment is what? Inspecting the food items, and this experiment carry 5 steps, 5 trials. Determine the number of permutations of the any 2 experimental outcomes that inspector want to examine. We discuss in the combinations also the same example. I'm again repeating to make it more clear that in here the total experiment are total large group of objects, that is 5, A, B, C, D, E. These are 5 objects, 5 food items, but inspector is choosing only 2 of them. So the question is this, that what are the total experimental outcomes of this experiment in the combination of 2 food items. I'm again repeating that inspector is inspecting the 5 food items, but inspector will choose only 2 from the 5, and this 2 is small n, and this is the selected group of items that we call items in combination form, items in group form. So the question is this: determine the total number of experimental outcomes of this experiment. Means how many combinations are possible if the inspector is choosing 2 items from the 5. So this is answer to this question, that the total objects n is equal to 5 and small n is equal to 2. So 5 is the large group of items, 5 objects, capital N, and small n is the combination that we choose from the 5, 2. 2 is the subset of the large set n. This 2 is the subset, group of the part of the n. We choose only 2 from the 5. So we will put n is equal to 5 and n is equal to 2 in the formula we have. This is the formulation we will put in here. Mathematical notation of the formulation is this: we will put n is equal to 5 and n is equal to 2. This is n factorial, and I am replacing for this n its value 5 in here. So this is 5 factorial. Now I am replacing for this small n factorial, its value 2. So this is sorry, this n factorial is not in here. This is typing mistake. This is not in here. This cancel out. This n factorial cancel out with this n factorial, and we have the formula n factorial whole divided by n minus n whole factorial. So this n is extra in here. This is we does not require this n factorial in this formula. This is typing mistake. Dear students, there is no need of this small n factorial. So 5 factorial divided by n is 5 minus small n is 2 and whole factorial. This is again one problem, that this is not C, this is P. This symbol is P, not C. C represent combinations, and we are studying permutation, so you have to use here the symbol P, not C. So P 5 2 is equal to 5 factorial, 5 minus 2 3 factorial. Again P 5 2 is equal to 5 factorial, we will expand 5 multiplied by 5 minus 1 whole multiplied by 5 minus 2 whole multiplied by 5 minus 3 and whole multiplied by 5 minus 4 and whole divided by 3 and multiplied by 3 minus 1 and multiplied by 3 minus 2. So now I am again repeating, dear students, this is not C. C we use for combination, but we are learning permutation. That is why this is typing mistake. This is P5 2. So this is 5, 5 minus 1, 4, 5 minus 2, 3, 5 minus 3, 2 and 5 minus 4, 1 divided by 3 and 3 minus 1, 2 and 3 minus 2, 1. So this 3, 2, 1 cancel out with this 3, 2, 1 and remaining only 5, 0, 4. So P 5, 2 is equal to 5, 4 and P 5, 2 is equal to 20. So the total number of permutations are 20. Now the difference between the combinations and permutation is this, that in permutation we will disorder the group of items, we will disorder the combination. So when we disorder the combination, this will be considered another experimental outcome. So let's stop the 20 permutations. I'm again repeating, dear student, this is mistake. This is PNN. PNN, this is not C. Replace this C for P. Write a P in here. This is permutation. This is permutation, permutation, permutation. Now list of 20 permutations. We disorder the combination. Let me take you back to the combinations. These are the 10 possible combinations: AB, AC, AD, AE, BC, BD, BE, CD, CE and DE. 10 combination of this example we developed. But permutations are 20. Why permutations 20? Because in permutation we will only disorder the combination of in object as this is in here. Again AB, AC, AD, AE up to this DE. These are the 10 first permutation, but when we disorder these permutation like AB, we disorder to BA. So BA is another experimental outcome in the group of items form. Our AC we disorder, we change the order. CA. CA is another experimental outcome. This is AD, we disorder to DA. So DA is another experimental outcome. This is AE, we disorder to EA. So this is another experimental outcome. And now when you count all them, these are the 20 permutations for the 20 permutations of the for the choosing two items, two group of items. So this is the only difference, that in combination we are determining the experimental outcomes of an experiment in the group of items form, in the combinations form, and in permutation we will again determine the experimental outcomes in combination form, but when we disorder those combination, so the experimental outcomes, number of experimental outcomes will increase, and the reason is only by disordering the in objects. So in here we represent that AB is one experimental outcome, but if we disorder to BA is another experimental outcome. That is why the 10 combinations double to 20 permutation. The only difference is order of the small n, that if we disorder this small n, so this will be considered another experimental outcome. Let me again repeat this counting rule for combination. Counting rule for combinations. Counting rule for combination is used to determine the experimental outcomes of an experiment, but in the combinations form, in the group of items form. And we will use for the large group of items the symbol capital N, and we will use for the group of items that we choose as combination small n. This capital N is used for the large group of objects, and this small n is used for combination that we choose from the large set of items. So combination counting rule for combination is used to list, to determine the experimental outcomes of an experiment in combination form. Means we will choose the small n combinations. We will choose this small n combinations from the large group of items n, and this is mathematical notation C and n. C represent for combination, and this is formula n factorial divided by small n factorial n minus n, where capital N is the large group of items and small n is the combination that we will choose. So in here C and n represent the combinations of n object or small n experimental outcomes from the large set of n objects. The small n is the combination, the group of items that we will choose from the large capital N, which is the large set of items or group of objects. And this is n factorial, we will expand like this, and this is small n factorial, we will expand n into n minus 1 into n minus 2 and so on. So we put here one example that suppose a food inspector is inspecting the 5 food items. So the total number of food items are 5. It's mean experiment is inspecting the food items, and this experiment carry 5 steps. But to make the thing easy, inspector choose only any two items from the large group of items A, B, C, D and E. So in here the capital N that represent the large group of items, food items, and small n that represent the combination of the group of items that inspector want to inspect. Now inspector can choose any two. Inspector can choose AB, but inspector can choose AC also. Inspector can choose AD also. Inspector can choose AE also. It's mean when inspector want to inspect any two, so different possibilities are different outcomes are possible that inspector can check first and second, first and third, first and fourth, or first and fifth. So different possibilities can exist. He can choose any two. So the question in front of student is this, that determine that how much total experimental outcomes are possible if the inspector is inspecting any two from the large group of items 5. So large group of items, we are using the symbol N for that, and the small group of items that inspector inspect, we use small n for that. Now n is equal to 5 and n is equal to 2. We will put in this combination formula. For n we replace 5, so this is 5 factorial. Whole divided by, for small n we replace 2 because small n is 2 factorial, and n5 minus 2 whole factorial. C for combination, 5 2 is equal to 5 factorial as it is, divided by 2 factorial, and 5 minus t 2 3 factorial. Now C5 2 is equal to 5 and 5 factorial, we will expand 5 minus 1 multiplied by 5 minus 2 multiplied by 5 minus 3 multiplied by 5 minus 4 whole divided by this 2 factorial, 2 multiplied by 2 minus 1 and multiplied by this 3 factorial, 3 multiplied by 3 minus 1 and 3 minus 2. Now we will further simplify. C5 2, again I am repeating, C represent for combinations. So 5 as it is, 5 minus 1 4, 5 minus 2 3, 5 minus 3 2, 5 minus 4 1 whole divided by 2 as it is, 2 minus 1 1, 3 as it is, 3 minus 1 2 and 3 minus 2 1. Now this 3 2 1 in the numerator in the surat will be cancelled out with this 3 2 1 in the makhraj or in the denominator. So what is remaining in the numerator in surat? 5 4 divided by what is remaining in the denominator in makhraj? 2 multiplied by 1. So 5 multiplied by 4 20 divided by 2, and C5 2 is equal to 10. So what does this 10 mean? What is its interpretation? 10 means that if food inspector is inspecting any two from the large group of items 5, so 10 different outcomes of this experiment are possible, and these outcomes are given in here. Inspector can choose A, B, first and second food item. but inspector can choose A, C first and third item. Inspector can choose A, D first and fourth item as well. He can choose A, E also. He can choose B, C. He can choose B, D. He can choose B, E, C, D. It means these are the different possibilities that can happen, that if inspector want to choose any two from the large 5 group of items. So inspector is inspecting the food item. This is an experiment, and this experiment in combinations in combination of 2 items can carry 10 combination. Experiment can carry how much experimental outcome? 10 combinations are possible, because inspector can choose any 2. Now let me again repeat this. Permutation. So permutation is another counting rule which is used to determine the total number of experimental outcomes of an experiment, but in combination form. In combination form, in the sense that we statistician can choose the group of items. So in here the only difference between permutation and combination is this, that in permutation experimental outcomes are more. Why? Because if we disorder the combinations, so it will be considered other experimental outcomes. And as we clarify in here from this example, that A, B, A, C, A, D, A, E, B, C, B, D, B, E, C, D, C, E, D, E. These are 10 combinations, but when we disorder them, we disorder A, B to B, A. This is B, A. This is another outcome. We disorder A, C to C, A in here. C, A is another outcome. D, A is another outcome. We just disorder A, D to D, A, and now this is another outcome. So that is the only reason that permutations are more than combination. Arrangement in here are more. We can arrange like this, these combination, but we can arrange like this. So when arrangement are more, that is called permutation. So in permutation, the experimental outcomes are double. The reason is when we disorder the combination, when we disorder the small n, when we disorder the group of items, so the experimental outcomes will increase or will double.